This week we'll be covering Chapter 7, Sampling, Estimating the Frequency of Behaviors and Beliefs. Last week we focused on construct validity and talked about different ways to ask survey questions. This week's topics focus on another important validity, external validity. If last week's focus was on how we ask a question, this week's focus is on who we ask our questions to. This chapter focuses on two main topics. First, generalizability, or if the sample is representative of the population. And second, interrogating external validity, or what's most important when we want our study to have good external validity. Let's first talk about generalizability, or the degree to which our sample represents the population. There are four main things we'll discuss. First, we'll cover simply what we mean when we say a sample or a population. We'll talk about when a sample may be biased, how we go about obtaining a representative sample, and when it might be acceptable to use an unrepresentative sample. So what do we mean exactly when we say population or sample? Well, a population is the entire set of people or things in which you are interested. For example, all freshmen currently enrolled at your college or university. It does not mean the entire population of the world, only the population of people you're interested in your research applying to. A sample is a smaller set of people or things that is taken from the population. For example, 100 freshmen currently enrolled at your college or university. You may have heard the term census used before, maybe the US Census, which is aimed at polling every member of the US population. And that's exactly what a census means here as well. If you sample every member of the population, for example, every college freshman currently enrolled at your college or university, then you are conducting a census. So when we conduct our research, it's important to ask ourselves what our population of interest is. So again, when researchers refer to the population of interest, they are not talking about the entire population of the world, but rather the population to which they want their research findings to generalize. So for example, a population of interest might be laboratory mice. It might be undergraduate men, or it might be women with dementia. All of these are different examples. This next slide shows table 7.1 from your textbook. Here we can see some examples of how a sample can be a biased representation of our population, as well as how we can avoid biases in our sample. For a sample to be representative of a population, it must come from that population. But researchers also need to consider how the sample was selected. Samples are either biased or representative of the population from which they are drawn. In a biased sample, or unrepresentative sample, not all members of a population have an equal probability of being included. In an unbiased sample, or representative sample, all members of the population have an equal probability of being included. We can only make inferences from the sample to the population of interest when we have a representative sample. So again, in the examples shown here, we can see how a biased sample includes some specific criteria people from the population of interest must meet to even have a chance of being sampled. In the bottom example, if a student didn't write a comment about their professor, then they would have no chance of being sampled, even though they are included in the population of interest. However, by selecting every 15th student, all students have some equal chance of being selected. You might be asking yourself at this point, how do I know if my sample is biased? Let's talk about two examples from the textbook that show how a biased sample and a representative sample might be collected for the population of interest. There are at least two different ways that we can get a biased sample, and a biased sample can threaten our study's external validity, or how well our findings can generalize to our population. One of those ways is by sampling only those individuals who are easiest to contact. This is known as convenience sampling. Think about this example. In the last 10 years, psychologists have been conducting research through websites such as Amazon's Mechanical Turk or Prolific Academic. People who want to earn money for participating in research can do so online. Even though these samples are convenient, people who complete studies on websites sometimes show personality traits or political beliefs that differ slightly from members of other adult samples. By using these sites to sample participants, we may be biasing ourselves in our sample. If these individuals who complete studies online for money hold views different from other members of the population, then by sampling only them, we miss out on the opinions of those with different views. We can also see in Table 7.2 how using a method of acquiring information, such as calling someone's home landline, may cause biased sampling to occur. Here we can see the different data values that would be collected based on the different methods of contact. The second major way we might get a biased sample is through self-selection. Self-selection is a type of biased sampling in which only people who volunteer participate in a study. Self-selection is especially prevalent in online polls. We see here on the bottom left an online poll that invited readers to vote on their plans for child car seats. Why can't we generalize from this sample of 17,000 to the population of parents of small children? Because this sample consists only of those who have volunteered to participate in the study. It's possible, and potentially likely, that those who choose to take part in an online questionnaire about car seat use may have different views, beliefs, or information than parents who have not chosen to take part in the survey. While self-selection bias is often common in online polls, there are some that use random sampling to help combat this bias. The data in the figure on the right came from an online survey on road rage. The respondents had been randomly sampled and invited to respond, so we can probably generalize from this poll to the population of American drivers. Additionally, respondents could endorse multiple behaviors on the list, which increases the construct validity of the results, since participants weren't limited in only one choice. Now that we've talked about some ways in which we can have biased samples, let's talk about how to avoid this and make sure we're obtaining representative samples. Remember, a representative sample minimizes biases and aims to accurately represent the population we wish to generalize our results to. When aiming to maximize external validity, researchers need to obtain a representative sample. The best way of getting such a representative sample is by using probability sampling, also known as random sampling, in which every member of the population of interest has an equal chance of being selected for the sample. There are a number of kinds of random or probability sampling. One kind is simple random sampling, which can be obtained by putting every member's name of your population of interest in a pool and then randomly selecting a predetermined number of names from that pool to include in your sample. Another way to obtain a simple random sample is to assign a number to each member of the population and then use a table of random numbers to select your sample. As you might be thinking, random sampling can be very difficult to do and also quite time-consuming. In some cases, it's impossible to do if you cannot enumerate or quantify your population of interest. In these cases, you might use variations of simple random sampling that are equally externally valid. So let's talk about some of these. Some other types of probability sampling include cluster sampling, where clusters of participants within a population of interest are randomly selected, and then all individuals in each selected cluster are used. If a researcher wanted to randomly sample high school students in the state of Pennsylvania, for example, they could start with a list of 952 public high schools or clusters in that state, randomly select 100 of those high schools, and then include every student from each of those 100 schools in the sample. Multi-stage sampling is when two random samples are collected. In stage 1, a random sample of clusters is selected from your population of interest. Then in stage 2, from those selected clusters, a random sample of people is chosen. For example, a researcher starts with a list of high schools or clusters in the state and selects a random 100 of those schools. Then, instead of selecting all students at each school, they select a random sample of students from each of those 100 selected schools. Stratified random sampling is a multi-stage technique in which the researcher selects specific demographic categories, such as race or gender, and then randomly selects individuals from each of the categories. For example, a group of researchers might want to be sure that their sample of 1,000 Canadians includes people of South Asian descent, in the same proportion as in the Canadian population, which is 4%. Thus, they might have two categories, or strata, in their population: South Asian Canadians and other Canadians. Oversampling is a variation of stratified random sampling in which a researcher overrepresents one or more groups. For example, perhaps a researcher wants to sample 1,000 people, making sure to include South Asians in the sample. Maybe the researcher's population of interest has a low percentage of South Asians, say 4%, like in the example in Canada. Because 40 individuals may not be enough to make accurate statistical estimates, the researcher decides that of the 1,000 people they sample, a full 100 will be sampled at random from the Canadian South Asian community. Lastly, there's systematic sampling. This uses a predetermined system to fairly sample people from the population. If I wanted to systematically sample this class, I could roll 2 dice. Let's say one lands on 5 and the other lands on 3. I would start at the 5th person in the class and then choose every 3rd person until the sample reached the desired size. One quick point I'd like to make here is that it's important not to confuse random sampling with random assignment. Remember, random sampling is creating a sample using some random method so that each member of the population of interest has an equal chance of being in that sample. This method increases external validity. Whereas random assignment is only used in experiments. Participants are randomly put into different groups, usually a treatment group and a comparison group, and this method increases internal validity. So when we're talking about random sampling here, we're not talking about assigning participants to groups randomly in an experiment. Sometimes, external validity is not our top priority in our study. If you remember back to when we learned about the different types of validity, I mentioned that you have to balance your methods and techniques based on which type of validity you're trying to maximize. Sometimes you may want to maximize the generalizability of your results, or your external validity, while other times you may put more emphasis on ensuring you have the best control over outside influence in your study, or your internal validity. In an ideal world, you would want to maximize both of these, but sometimes trade-offs need to be made. If external validity is not a top priority, then unrepresentative or biased sampling may be used. Some examples of this include convenient sampling, which is using samples that are easy to access, and this is a common technique in behavioral research. Purposive sampling is used when you want to study certain kinds of people, so you only recruit those types of participants. For example, if you wanted to recruit smokers, you might recruit participants from a tobacco store. Snowball sampling is a variation on purposive sampling, in which participants are asked to recommend other participants for the study. For example, for a study on coping behaviors in people who have Crohn's disease, a researcher might start with 1 or 2 people who have the condition, and then ask them to recruit people from their support groups. Each of them might in turn recruit 1 or 2 more acquaintances, until the sample is large enough. Snowball sampling is unrepresentative because people are recruited via social networks, which are not random. Finally, we have quota sampling, which is similar to stratified random sampling. The researcher identifies subsets of the population and then sets a target number, or a quota, for each category in the sample. Then they use non-random sampling until the quotas are filled. For example, you would like to have 20 college freshmen, 20 sophomores, 20 juniors, and 20 seniors in your sample. You know some people in each of these categories, but not all 20 of each. So you might use snowball sampling until you meet your quota of 20 in each subset. It's important to understand that sometimes these different methods of sampling are going to be combined and used together. This table provides an overview of each of the different sampling techniques and how they each fall under either probability sampling, which provides accurate representation of the population, or non-probability sampling, which provides a biased representation of the population. As I said on a previous slide, sometimes we have to decide which validity our priority is. So how do we know when external validity is our priority? Well, we know that external validity is very important when making frequency claims, because you're reporting on how often something happens in a population. So for example, if we report that 8 out of 10 drivers say they experience road rage, if the driving study used sampling techniques that contain mostly urban residents, the road rage estimates might be too high because urban driving may simply be more stressful. On the other hand, when might external validity be a lower priority? Even though you need a probability sample to support a frequency claim, Many associations and causes can still be accurately detected even in a non-probability sample. Let's consider non-probability samples in the real world. When you know a sample is not representative, you should think carefully about how much it matters. Are the characteristics that make the sample biased actually relevant to what you're measuring? In certain cases, it's reasonable to trust the reports of unrepresentative samples. For example, let's say a driver uses the Waze navigation app to report heavy traffic on a specific highway. Well, this driver is not a randomly selected sample of drivers on that stretch of road. In fact, they're more conscientious and thus more likely to report problems. However, these traits are not that relevant. Traffic is the same for everybody, conscientious or not. So even though the driver is a non-random sample, their traffic report can probably generalize to the other drivers on that road. The feature that has biased sample, being conscientious, is not relevant to the variable being measured, being in traffic. Now let's consider non-probability samples in research studies. Recall from Chapter 6 the 30 dual earner families who allowed the researchers to videotape their evening activities? Well, only certain kinds of families will even let researchers walk around the house and record everyone's behavior. Does this affect the conclusion of the study? It seems possible that a family that volunteers for such intrusion has a warmer emotional tone than the full population of dual earning families. Without more data on families who do not readily agree to be videotaped, we cannot know for sure. So here the researchers may ultimately have to accept some uncertainty about the generalizability of their data. Finally, let's quickly talk about sample size. Many people think that a larger sample is always going to be more representative than a smaller one. However, this isn't always the case. We need to take into account how that sample was obtained. Was it a random sample or a biased sample? The sampling technique that was used is more important than the sample size itself. So let's wrap up this week's topics. We first talked about generalizability and if the sample is representative of the population. We discussed what populations and samples are. We also talked about the characteristics and sampling methods that make a sample biased or representative, as well as when it might be acceptable to settle for an unrepresentative or biased sample. We also discussed how we can interrogate external validity in a study and when to know if external validity is a priority over other types of validity. Lastly, we mentioned that larger samples are not always more representative than smaller ones, and that it's the sampling technique that matters most.